Yeah, welcome to today's practical class. In today's class, we want to verify the principle of moment. That is the aim of this practical is to verify the principle of what? Moments. Now you have a meter rule. This is your meter rule. This meter rule, first of all, use knife edge and determine the center of gravity without anything on it, any load. So when you determine the weight, the mass of the what? The center of gravity. You determine the center of gravity of the meter rule. After that, you now place a mass of 50 gram. Mass of 50 gram at 1 cm. As you can see, from here to here is 1. This is 0. This is 100. So from here to here is 1 cm, meaning that you have to place the load at 1 cm. Do you get it? When you place the load at 1 cm, you begin to adjust the meter rule until the meter rule balances horizontally. Wherever the meter rule balances, you now record from here to here at this point. In mass of 50 gram, you record the length. Then you repeat the whole process for a mass of 70 gram. You put a mass of 70, adjust the knife edge until it balances horizontally. You now record from here to here. And that will give you repeat the process for various values of what? Masses. Do you get it? Then after that, you now take the reciprocal of this. If this place is 30 cm, you now say 1 over 30 cm, whatever you get, you write it at this place. So that is what you are going to carry out in this experiment. Do you understand? Yes. So that is verification of principle of moment. Avoid droughts. Avoid droughts. Make sure that the meter row is horizontally balanced, not momentarily balanced. Okay. What is the reading? Okay. 30 cm, right? Yes. I record it on the board. Now put a mass of 70 gram. Then balance the body on the knife edge. For a mass of 70. That mass is what? What is that mass? That is a mass of what? 90, right? Okay, what is the reading?
26. 26.
26, right?
Yes.
For a mass of 90, what is your reading?
22.5.
20 what?
22.5.
For mass of 110, what is your reading?
21.5.
Then the last one, a mass of 130, what is your reading?
20.03.
Okay, take the reciprocal of x. That is 1 divided by 30.
One divided by 20. 0.043. 0.048.
47.
0.053.
Okay, this is the complete table of value, right? Against inverse of what? X. If you use a straight line equation where you have mx plus c, it means this is graph of this against this, meaning that your slope, this is your slope. This one is the intercept on the vertical what? Axis. The intercept on the vertical axis is mass of the meter rule. While the slope will also give us mass of the meter rule. We can now say that our slope will give us this one will be equal to 50m. So when you make your m the subject, you now have m becomes slope over what? 50. Now this is also how to get the mass of the meter rule. So let us plot the graph and see how it goes. Okay, we are plotting a graph of m against inverse of what? X. Now this is the vertical axis, which is m in gram. This is the horizontal what? Axis. Okay. So in the vertical axis, we have taken a graph of m against inverse of x, where you have 2cm. We use 2cm to represent 20 units, as you can see. This is 20, 40, and so on. This is the negative aspect. Then we have 2cm to represent 0.01 along the horizontal axis. Now when this one is 50, this is 0.03. We have 50, this is 40. Each line here, how do you get each line here? If you want to get each line, you now count the number of lines before this 20. That is how many? It's 10, right? Now you say 20 divided by 10 is what? 2. That means each small line here is 2cm. Now what to do is, then this is 20, this 40, plus the next one, that is what? 40. That is 40. So this is the slope. We've taken our slope. The value of our slope is this one. As you can see, this is the theory behind the experiment, which is m equal to 50m, mass of the meter rule, and this. So notice that when this one is 0, or when x is 0, this m becomes equal to this. When m is 0, when the inverse of x is 0, we now try to locate the mass at that point. The mass, when this one is 0, will give us the value of this. If this one is 0, that means m is equal to this. The intercept on the vertical axis is this one here. This intercept will give us the mass of the meter rule. Do you get it? This is the mass of the meter rule. Then we can now use this one. When m is 0, we try to make this one the subject of the formula, and that will give us the intercept on the horizontal axis. Intercept on the horizontal axis is this point here, and we read it 1 over x is equal to, we read this point, whatever it gives us. Now 1 over s, let's say this point is, this is 0.2, okay, 0.02, so 0.02. We are looking for x. We now take the reciprocal of 0.02. S will give us 1 over 0.02, and that will give us the value. Whatever it gives us is the center of gravity of that object. Please, can you confirm that? What is the value? We say 1 over x is equal to the intercept. So that will give us 1. Now, if we are looking for x, we take the reciprocal, that is 1 over this. And the 1 divided by this will give us 50. And this 50 is the center of gravity, which you have already determined during your what? Experiments. Do you get it? Now that means the value here agreed with the theory. So that is